You start by denoting the alleles. You have a recessive allele, lowercase k, and a dominant allele, which is uppercase K. Next, you denote the genotypes. There are three possible genotypes. One is homozygous dominant. Which is uppercase K. You have heterozygous, which is uppercase K, lowercase k, and then you have homozygous recessive, which is lowercase k. Next, you perform a monohybrid cross. We've been told the two parents were both heterozygous. Therefore, this is the genotype we use. Both uppercase K, lowercase k. This is the dad. Uppercase K, lowercase k. This is the mom. Then you do the crossing. Take the first allele, cross it to the first allele of the second. You get uppercase K. Same thing for this one. Uppercase K, lowercase k. This one, you get uppercase K, lowercase k. And the last one, lowercase k. What you want to know, which one of these is affected and which one is unaffected. But we're told the condition is caused by a recessive allele, lowercase k. Therefore, these are the affected children. These three are unaffected. Next, we determine the probability of being unaffected, which we denote as U, and the probability of being affected, which we denote as A. The probability of being unaffected is 1, 2, 3 out of the possible 4, therefore 3/4. The probability of being affected, A, is 1 out of 4. Then we determine the number of trials. The number of trials, N, is equals to the number of children that they plan to have. N is equals to 5. From then, we can use three methods to solve. One is this one here, Pascal's triangle. 2 is the factorial approach. 3 is the forked line method. But this one is a bit hectic, so we'll focus on these two. Let's start with the first one, Pascal's triangle. Pascal's triangle is used for solving binomial expressions. A binomial expression is an expression of the example a plus b to the power n. This is a binomial expression. If you had a plus b plus c to the power n, that would be a trinomial expression. This triangle is for solving a binomial expression. For instance, if you are asked to expand a plus b to the power 0, the answer would be 1, because any number to the power 0 is 1. A plus b to the power 1 would give you the same number, a plus b. A plus b squared would give you a squared plus 2ab plus b squared. A plus b cubed would give you a cubed plus 3a squared b plus 3ab squared plus b cubed. A plus b to the power 4 would give you a to the power 4 plus 4a cubed b plus 6 a squared b squared plus 4ab cubed plus b to the power 4. If you notice, they are forming a triangle here. If you took the coefficients from these expressions, you would get 1. The coefficient of a and b is 1 and 1. the coefficients of a, b and b squared is 1, 2 and 1. The coefficients here it's 1, 3, 3, 1. The coefficients here are 1, 4, 6, 4, 1. And if you notice, if you add two numbers in a row, for example 1 plus 2, you get the next number in the next row. 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And you can even continue the triangle. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, 1 and 1, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, 1, 1. The triangle formed here by these coefficients is called Pascal's triangle. It's used to expand equations or expressions of the form of a plus b to the power n, binomial expressions. For example, let's try a plus b squared. A plus b squared using Pascal's triangle. First, you write out ab 3 times, that is 2 plus 1 times ab plus ab. Next, you write out the powers, starting with the highest power, 2. The powers of a will be decreasing by 1 up to 0. The powers of b will be increasing by 1 up to 2. But the two powers must add up to 2. 2 plus 0 is 2, 1 plus 1 is 2, 0 plus 2 is 2. Next, you fix the coefficients from this row here, third row. So it's 1, 2, and 1. The answer becomes a plus b squared is equals to a squared, because b to the power 0 is 1, any number to the power 0 is 1, plus 2ab plus b squared. And the same as this one here. The next example, we can take a plus b power 4. Write out ab 5 times, 4 plus 1 times ab plus ab plus ab plus ab plus ab, 1, 2, 3, 4, 5. Start with power 4 for a, decrease the powers of a by 1, 4, 3, 2, 1, 0. The powers of b, starting with 0, increase by 1, 1, 2, 3, 4. Then you come back to your triangle, the fourth row, the fifth row, fixing the coefficients 1, 4, 6, 4, 1, and you get the answer to be a plus b to the power 4 is equals to a to the power 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the power 4, which is the same as this one here. Next, we come back to our question here. You notice, since we only have two probabilities, probability of being unaffected, which is u, and the probability of being affected, which is a, we can also form a binomial expression from here, which is u plus a to power n, and n is 5. They have 5 children. U plus a to power 5. And if you expand, you get u plus a to power 5 is equals to, first write ua, 6 times 5 plus 1 times ua, 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 ua. Start with power 5 for u, decrease the powers by 1, 5, 4, 3, 2, 1, 0. For a, start with 0 up to 5, 0, 1, power 2, power 3, power 4, and power 5. But the powers must always add up to the original power, which is 5. So 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2, 2 plus 3, 1 plus 4, 0 plus 5. All must equal 5. Next, you plug in the coefficients from Pascal's triangle, which will be 1, 5, 10, 10, 5, and 1. So the answer becomes u plus a to the power 5 is equals to u to the power 5, because a to the power 0 is 1, plus the coefficient here is 5, u to the power 4 a plus 10 u cubed a squared plus 10 u squared a cubed plus 5 u 8 to the power 4 plus 8 to the power 5. These are our answer. We come to part A. Part A asks, what is the chance that all the children will be unaffected? So we are looking for the probability that all are unaffected. All means 5 in this case because they have 5 children. So the probability all are unaffected is equals to u to the power 5. This one here. And u to the power 5, we know u is equals to 3 out of 4, so is equals to 3 out of 4 to the power 5, which is equal to 243 over 1024. Part B, what is the chance that 4 children will be unaffected and 1 affected with a condition? So we want the probability that 4 will be unaffected and 1 will be affected. The expression that has 4 unaffected and 1 affected is this one here, the second one. So is equals to 5 u to the power 4. A is equals to 5 multiplied by u is 3 out of 4 to the power 4 multiplied by 1 out of 4, which is equal to 405 to the power 45 over 1024. Part C, what is the chance that at least 3 children will be unaffected? At least 3 means you can either have 3 unaffected, 4 unaffected, or 5 unaffected. So probability at least 3 will be unaffected is equals to probability 3 are unaffected or 4 unaffected or 5 unaffected. From part A, we have the probability of 5 being unaffected here. From part B, we have 4 being unaffected. So we only need to get the probability of 3 being unaffected. So the probability of 3 being unaffected is equals to this term here, this expression, 10 u cubed a squared is equals to 10 multiplied by 3 out of 4 cubed multiplied by 1 over 4 squared, which is equal to 27. Zima hiyo kwanza.